What if scientists could take cells from tissues, like for example your arm, and later use those cells in different parts of your body, like your heart, muscles, or even your skeletal system? Well, that's where iPSCs come in. In this speech, I will discuss what iPSCs actually are, what they do, how they're made, and why you and I should know more about them. Before I do so though, let's talk about why this relates to you guys as the audience. Well, iPSCs, or induced pluripotent stem cells, can be used for many different things, like bettering medical treatment or curing diseases in general. So now that we know a little bit about what this speech will cover, let's go into what iPSCs actually are. Induced pluripotent stem cells are cells that have been taken out of your body in different areas and then reprogrammed by adding genes to become pluripotent. What does pluripotent mean? Well, pluripotent means that those cells can go anywhere else in your body. In the example before, I used your arm cell tissues. Well, those arm cells couldn't be used anywhere else before, but after they have been reprogrammed with different genes added into them, they become pluripotent, which means that they can be added into different areas, like for example your muscle or your heart tissue. iPSCs were first discovered in 2006 by scientist Shinya Yamaka. So more about how these cells are created. Here's a diagram here, which I'm going to discuss. So we first take adult cells, specifically skin or blood cells. In the article iPSCs, UCLA STEM Research Center describes why we do this, which is because these skin or blood cells have already been fully developed, unlike different cells. But why do we want to use those? Well, because they're easier to use because they are fully developed and lack different issues that undeveloped cells could cause. So to start, we take these skin or blood cells and then we reprogram them by again adding genes into them, then they become pluripotent. But why do we want them to become pluripotent? Well, we want this because it makes the cells mimic embryonic stem cells, or embryonic cells in general. What is an embryonic cell? Well, in the article iPSCs by Thermo Fisher scientists, we discuss more about embryonic stem cells. Think about when you're an embryo or in utero and you're an embryo yourself. Well, your cells are just getting organized into the different areas of your body, so they're almost pluripotent in a way. In iPSCs, we want to mimic that beginning feeling because those cells can go anywhere, which helps us to treat many different diseases and aid medical treatments, as we said before. Here's another diagram about how they're made, just so you can get another example of how they're made, because this is a bit of a crazy topic when you think about it. Once these iPSCs are made, they can then be used to treat and aid many different diseases, such as Parkinson's, congestive heart failure, or even hypertension, allowing for a better quality of life for people like you and me, or anyone who suffers from diseases like this that could degenerate your body. But they can also aid with things that are outside of your body, like drug tests. In the article Human iPSCs, the ATCC Center discusses this topic in further depth. They discuss that instead of using drug testing on different subjects like mice, rodents, or even humans in some cases, they can implant different drugs or diseases into the iPSC cells instead of using live test subjects. Now, this is better because it benefits the different live subjects, but we can also see the full histology or the history of what's going on with the cell. Seeing that histology helps us and the scientists get a better definition of what's going on outside of the body and a definition of how we can treat it. Again, in this speech, I covered what iPSCs are, how they're made, what they do, and why we should know about them. Again, we know that iPSCs are taken from adult cells and they are reprogrammed, and then they can be used in many different areas of your body to help with different things that people might be suffering from. Thank you for listening, and I challenge you to do some further research on iPSCs and how they can benefit people like you and me. Thank you.